glad you could join us today for the webinar, and hope I can give you a few some new information and some pointers for the design for horizontal shear and shear friction in concrete structures. So let's go ahead and get underway. So outline of our presentation, we're going to talk a little bit introduction, some applications, and kind of the history of how we got to the horizontal shear and shear friction provisions that we currently have in the codes, some key concepts and analysis, and the design for horizontal shear. Then, as Maria said, we'll take a short break and then come back and wrap up with design for shear friction, a few detailing things that are required by the codes, and then summarize this all up for our session today. So why are we going to spend the next 2 hours talking about shear friction? It seems like a pretty specialized subject, and is it something that's really necessary to talk about for 2 hours? So it really comes down to this primary section from ACI 318. It's in section 22.9, one of the part of the toolbox chapter that they like to call it, chapter 22. The number 9 subsection under there, shear friction, is, it shall apply where appropriate to consider shear transfer across any given plane, such as an existing or potential crack, an interface between dissimilar materials, or an interface between two concretes cast at different times. So it's a really kind of catch-all provision that you can see there. Any given plane, existing or potential crack. It's got that kind of language that makes something that might need to be considered for a large variety of applications. We're going to go through some kind of specific applications for it, but this is where 318 kind of introduces this idea of shear friction for concrete structures. Looking over on the commentary side, it's got a little bit more guidance about what they're thinking and talking about there, right? It's a method to address failure by shear sliding on a plane. It's often when we're talking about shear friction, it's an intentional plane, but that plane could also be formed by cracks in monolithic concrete. And then it talks about some of the early references there. And it's really this bold statement or a couple of statements that's in commentary that really drives the point home, is that there's always a possibility that a crack will form in an unfavorable location, and this shear friction crack assumes that crack will form and that we're going to provide reinforcement to resist displacement of that crack. I think probably most folks on the call know concrete's quite weak in tension. We really don't rely on its tensile strength very much. And so the assumption that something would cause that crack to form, whether it's volume change, shrinkage, temperature-related volume changes, loading-related conditions that could potentially cause that crack to form, whatever happens that causes that potential crack to form, we're going to provide some reinforcement to resist its displacement and ensure we have some strength across that potential plane. So kind of through the webinar today, I know I started kind of with the shear friction side of it. I originally was just going to call this kind of the interface shear webinar, but that's not a term that's used as often in ACI 318, but that really encompasses both the traditional shear friction concept that I just talked about back in section 22.9, and also the horizontal shear section that we're going to touch on today, which is up in section 16.4. They're very similar behavior mechanisms. The demands that you're designing them for do differ a little bit, and the applications where you would apply the provisions do differ. Of course, horizontal shear is intended for a horizontal plane, but the concepts are really the same in the way that the force is transferred across that interface between whether it's cracked concrete, two concretes cast at a different time, or whatever that interface is created from. So in general today, I'm going to kind of refer and talk about shear interface shear, but there's going to be some aspects of both shear friction and horizontal shear that we will be talking about. So first, kind of what are some of the applications where we see this used in design? The first one is reinforced concrete corbel. This comes right out of section 16.5 of ACI 318. And they give us a clear indication here of where this potential shear plane will occur. So even if this corbel is cast monolithically with this column or wall, we have an assumption of where this existing or potential crack, as they like to describe it, would potentially form in concrete. And actually, when you're going through the design of a corbel, 318 requires the overall height of this corbel to be designed based off the shear friction transfer strength that you can get across that potential shear plane that they're showing there. So that's kind of the first primary mechanism of where we see a shear friction transfer.